everyone, what's up? All good? Great. So today we will be solving the question trapping rainwater. So let's see what is this question. Given n non-negative integers representing an elevation map where the width of each bar is 1 and compute how much water it can trap after raining. So you have been given n non-negative integers which represents the kind of a bar and you need to find how much water it can trap when it is raining. So let's see how we can do it. Okay. So you have been given this elevation map and like whenever it is raining, it will going to trap water, right? Because there are spaces around them. So let's see. So as we can see here, let's start from the first one. So over the first one, it cannot store any water because it will flow out from this side. So it cannot store any amount of water. Now over the second one, you can see that it is also not storing because there is no kind of gap over it. Okay. So in the over the third bar, you can see it is storing one amount of water, and here it is storing one amount. Here it is storing 2 units of water. Here it is also storing 1 unit, and here it is also storing 1 unit. So, but how we can calculate this amount of water? So you can see that let's say its height is 0. So you can see that here to the right of it, its maximum is this 3 bar, and here to the left of this, its maximum is this 2 bar. So among them, whichever is minimum, right? Among them, whichever is minimum, which is 2 here, minus the height of that one is the unit of water storing above that part, right? What I have said is minimum of left of I, comma right of I minus height of I, right? Let's see for the other bars as well. Let's say here its height is 1 and its left maximum is 2 and here its right maximum is 3, right? So whichever is minimum 2 comma 3, right? 2 minus height of that bar which is 1. So here 1 unit of water is tapped over it, right? And for here 2 comma 3, minimum of 2 comma 3 is 2 and minus 2 which is the height of this bar 0, sorry. So water trapped over this bar will be 2 units, right? Here it is 2 units. So you can see that for each bar, we need to calculate the amount of water trapped over that one. Okay. So what we can do is we can start iterating this elevation map. And at each bar, we need to calculate the left maximum and the right maximum, right? So whenever after I start iterating this array, we start iterating array from I to 0 for the left max, right? And then I2 and for the right max, right? And then find the minimum of them and then add the value in our result, right? Minimum of left max and right max minus height of I, right? So you can see here that it is giving us n square time complexity because first we are using this one loop for iterating the complete map and then we are using another loop for finding the left max and then right max, which is a nested loop. So its time complexity will become big of n square and its space complexity will be big of 1 as we are not using any extra space. Right. So what we have done is we have just gone to each bar and then calculated the amount of water trapped over that one. Right. For that we have first calculated left max and then right max and then simply add them in our result. But this O of n square time complexity is not going to work. So what we can do is, as you can see here that we are calculating left max and right max for each bar. So can we do some pre-computation for this left max and right max so that we can get this in big of one complexity? Yes, we can do it. Let's see. So how will left max and right max look like? So for this, we just need to start iterating from starting, so we can simply calculate the left max pre-compute. So we can simply do the pre-computation for left max. So let's see. It will be 0, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, and 3. And the computation for right max will look like something. One, two, 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 three, 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 and three. So this will be the pre-computation of left max and right max, right? So now we can simply start iterating this array and then access the left max and right max in big of 1, right? And then simply subtract the height of that bar. In this way, we will be simply getting the amount of water trapped over that. So as you can see here that whenever we are at this, then we will get the left max and right max, which is 3 comma 1. Minimum of this will be 1 minus height of that bar, which will be 0. Right? Now see this bar, 2 comma 3. Minimum will be 2. Height of this bar is 1. Water stored over this will be 1. Now here you can see minimum will be 2 comma 3. To 2 minus height of what will be 0. Now this one minimum will be 2 comma 3, which is 2 minus height of what is 1. Now this one, see, 2 comma 3 minimum will be 2 minus height of what will be 1. For rest of the bars will be 0, as you can see. 3 comma 2 minimum will be 2. 2 minus height of what 2 0. And see here as well, 3 comma 1. Minimum will be 1. Height of wall is also 1. So 1 minus 1 will be 0. So rest of them will be 0. So you can see is 1 plus 1 plus 2 is 4 plus 2, 6. So it will be 6 amount of water stored in this elevation map. Okay, so let's see its code. So first of all, I've just stored the height size of the height array in my n and then created two vectors left max and right max for the pre-computation of their values and then simply pre-computed their values. As you can see, I need to initialize the left max of 0 with height of 0 because there is nothing in its left and right max of n minus 1 to the height of n minus 1 because there is nothing in its right? So I have initialized these values and then simply computed the final amount of water stored in that elevation map by this method. Okay, so now what will be the time and space complexity for this? Time complexity will be big of n for this loop, right? And then big of n for this one, and then big of n for this one, right? So its overall time complexity will be big of 3n, or we can say that big of n, kind of. Okay. Now what will be the space complexity? Its space complexity will be big of n plus big of n because we have created two vectors. Or we can say that it is approximately equal to big of n. Right? Okay. But the interviewer will not be happy with this because of 2n space complexity. So can we do some optimization to reduce this space complexity because time complexity can't be reduced. It is already big of n. So can we reduce this big of n space complexity? Okay, so let's see if we can reduce this space complexity. Okay, so now let's see how we can optimize that space. So for this, I will first tell you the approach, how we can optimize it, then we tell you the intuition behind that approach. Okay, so for this, I need to initialize two pointers, left and right. Okay, and two variables, left max and right max. In the previous approach, we are introducing them as vectors, but in this approach, we are introducing them as variables only. Okay, so in this approach, what we will be going to do is, right? Well, as you know, in two pointer, what we do? We move the pointers based on some condition. Okay. So here, what will be the condition? So here the condition will be like moving the pointer which is less. If left max is less than right max, then we will move the left pointer. Otherwise, we will move the right pointer. Why? Okay. So you can see in the previous approach, this minimum is the condition on which we will calculating the amount of water stored over that one. Because minimum is giving the amount of water stored at that position, and by subtracting this height, we will be knowing the amount of water stored over that bar. So you can say that minimum is the limiting factor. And what we need to do is we just need to find that height, or we can say that minimum of minimum of maximum of left to the maximum of right. Okay, so we need to find that height. So if we are moving the pointer which is minimum, so eventually we will be getting that value because we are moving on that basis which is minimum. So we don't care what is in middle or what is in right, we don't care. We are getting that to minimum, or I can say that maximum height to the left and right by moving the pointer which is minimum. Okay, so let's see. Let me guide on this approach so that you can get a better idea of it. Okay, so initially left max will be 1 and right max will also be 1. So here they both are 0, but let's suppose this is 3 or this is 4 or this is some anything greater than left max, then I will be moving left pointer. Here they are both 1, so I can move any one of them, but let's say I will start from left pointer. Okay, so let me just initialize our result variable as well. Okay, so now we are at this. So it means we have encountered the area till here, and right pointer like we have encountered the area till here. Okay, so now we are at left point. So now we will calculate the result. Okay, so now here we will moving the left pointer. Both are equal, we can move in. So here I have moved the left pointer. Now the left pointer is pointing to this index. Now we will calculate the water stored over this S stack, or we can say this bar and thing. So what will be the value is left max minus the height of that bar, which will be 1 minus 0, which will be 1. Now our left pointer is minimum, right? So we will again move our left pointer to this position. Now left pointer is pointing to this. Now the height of left pointer is 2, so we will increment our left max. So now as you can see, our right max is max minimum then is less than left max, right? So now we will move our right pointer. Okay. And calculate the amount of water stored over this stack or this bar. So the what will be the amount of water? It will be 1 minus height of this bar, which will be eventually 0, right? So now our right pointer is at this. Now its height is 2, so we will increment our right max. Now they both are equal, so we can move any one of them. So let's say I will move left pointer. Now we will calculate the amount of water stored over this stack. So it will be left max minus height, which is 2 minus 1, which is 1. Okay. And now our left is still less. So now we will again move our left pointer. So now as you can see here is that again we will calculate the amount of water over this, which is 2 minus 0, which is 2. Now again we will move over left pointer. So again calculate the amount of water, which is 2 minus 1, which is 1. Now again move over left pointer as it is less than right pointer. Now as we can see here height becomes 3. So we will update our left max, which is 3. Now here our right pointer is less than left pointer. Okay, so now we will move our right pointer and calculate the amount of water, which is 2 minus 1, which is 1. Now again move our right pointer. Now again calculate the height of water, which is 2 minus 2, which is 0. Now again move our right pointer. Now our left and right pointer are both pointing to the same stack. And what will be the condition? The condition will be when left pointer is less than right pointer. Now whenever these two pointers collide, we will just came out of this loop. And as you can see here, we have got our answer as 1 plus 1 plus 2 plus 1 plus 1, which is 6. So here it is 6 amount as 1, 1, 2, 1 and 1. So you can see we have got our correct answer with the help of two pointer approach. And in this, we have not used any extra space. We have reduced our space complexity to big O of 1. Right? So let's see its code. So you can see here is that I have just initialized the left pointer and right pointer to 0 and n minus 1 and then initialize two variables left max and right max. Okay. Now, if height of left is less than height of right, then what we will be doing? We will be moving the left pointer. And if height of left is greater than height of max, then we are updating our left max and then calculating our amount of water stored over that stack. Otherwise, if right height of right pointer is less than height of left pointer, then we will be moving the right pointer, and if height of light is greater than light max, then we will be updating our light max value and then calculating the amount of water stored over that stack. In this way, we will be getting the sum of amount of water stored over each and every stack, and then at the end we will be returning our result. So what will be its time complexity? Its time complexity will also be big of n. So as you can see, we have reduced time complexity as well to some extent, because in the previous approach it was big of 3n. But as we don't count 3, but somehow we have reduced it to big of n exactly. And space complexity is reduced to a greater extent from 2n to big of 1. Okay. So this was the third approach was a little bit tricky, but yeah, that was all for this question. I hope you get it, but if you still have any doubts, you can post in the comment section. I will surely try to answer them. Till then, bye bye guys. See you soon in the next video.